What's poppin', dogs? Mr. Allen here, about to find the volume of a frustum. Okay? What? What the heck is that? Well, a frustum, okay, one of my favorite F words. It's factor, then it's fraction, then it's function, and then frustum. Okay, that's top four. Top four. A frustum is basically looking like a lampshade. Okay, so you ever see like an old lampshade? That's a frustum. I also equate it to like the trapezoid of the solids world. Okay, it's a cone that's been chopped off. Right, you take a cone, cut it off. That's a frustum. All right. So now we understand what a frustum is. Hopefully. Anywho, the top circle has a radius of 4 inches. The bottom has a radius of 12 inches, and the distance between these two is 10 inches. All right. Well, let's get to work. So I've got 4 inches, 12 inches, and 10 inches. By the way, I don't know if you know, this took me a long time to draw, okay? So please appreciate my frustum here, okay? This is doing the compass, had my straight edge. All right, got this guy all like, whoa, dialed in and all that stuff. I went for it, man. All right. What do I do here, okay? There is no formula, straight ahead formula for a frustum. However, I did mention something about a cone, chopping it off. What if I were to extend this thing here? Okay, I'm going to extend it out, and you may see a little tiny green dot that I had there. It was on purpose. It was so that I could line it up later. Sneaky Mr. Allen, you know? I'm seeing ahead on these things. Because I wrote the problem, right, I can see ahead into the future of said problem. And what I'm doing here is I'm going to extend this out, and now I can basically see an entire cone sort of formation happening here. And I'm going to draw in this height all the way down to the center of the small circle. And now, perhaps we can math with some stuff, you know? All right, well, define the volume of a cone. Let's actually write that down. The volume of a cone is big B times H over 3, okay? So it's the area of my base, which is a circle, times the height of my cone, and then I divide that all by 3. I don't have a height. So, once again, we are kind of in trouble here. I'm going to put this in orange. We'll call this H, okay, of my little guy, all right? And then the overall height would be from here all the way down to here, right? So this is just the height of my little cone here. Perhaps actually I'll make this just a variable. Let's call it X. I don't want to confuse it with the, like, there's 2 different heights we're going to deal with here. Okay, so, now what? Check this out. It may be hard to see in this 3-dimensional drawing, but I have a right triangle here, and this is also a right triangle. So a little right triangle, big right triangle, like a cross-section situation going on here. I'm going to draw up what I see here, just off to the side. So hopefully you can see it as well. But I have an X here, a 10 here. This is 4, and this is 12. If you're thinking, are those similar triangles, the little guy up top and the whole big guy? You are correct. We can set up a proportion to solve for X. Let's do it. So I can do the small triangle, X over 4. And then the big triangle is X plus 10 over 12. Okay, that is a common mistake right there, to not include the 10 or to not include the X. A lot of people say, okay, X over 4, 10 over 12. No. That 10's not the full side of the big triangle there. So you got to have the entire side of that big triangle and that base. All right? Cool. Awesome. You could have also set it up as X over X plus 10, 4 over 12. That works. It cross multiplies out the exact same. So X times 12 is 12X. Then I have 4 times X plus 10. So if you can, feel free to distribute the 4 in. So we'll have 4X plus 40. Or you can do 4 parentheses, X plus 10 distributed in. I'm going to subtract this guy right here. So if I subtract 4X, you show my work. Work. Like Rihanna. Always showing work. Divide by 8, and I get X equals 5. Beautiful. Beautiful. Should erase this little, it's not working. That's actually not too bad. X equals 5. Yay! I was just hiding it, right? Cool. So now I can find the volume of this cone, and the overall height of this guy is 15, right? The whole thing is 15. I can find the volume of both cones. But what I'd like to write down now, guys, is, I know I said there's no formula for it, but we can kind of sort of work with something here. Essentially, our idea is volume If you don't see it yet, but we'll see it. If I took the volume of the big cone, the whole thing, volume of the big cone, and I subtract the volume of the small cone, would that give me the frustum, right? Yes, it would. Yes, it would. So let's find the volume of the big cone first, okay? So we'll call it V. I shall do a different color here. We'll keep the pink for the small cone. I'll do blue. Okay. V big cone equals, and then let's see here. We said area of the base, so that's 12 squared times pi times my height, which is 15, all over 3. Excellent. Okay, and then let's finish this guy out here. So 12 squared is 144. Let's see here, 144 pi times 15 over 3. I'm going to leave this for now. I'll tell you why in a sec here. 144 times 15. I know you might be like, oh, could I divide by 3? You can. 2160 pi over 3. And this is divisible by 3. 15 is divisible by 3. 144 is divisible by 3. So I could simplify it down to 720 pi. But I'm going to hold off for just a sec. Because sometimes one of these two cones, the volume is, it's not divisible by 3 over here. So then you're going to have to go back to a common denominator. It's a whole thing. All right. So now let's do the volume of the small cone in pink. So volume small equals, here I have my radius of 4, so 4 squared times pi, or pi times 4 squared, and my height is 5 over 3. This is going to be, let's see here, 12 times 5, sorry, 12. 16 times 5 is, let's see here, 16 pi times 5 over 3, and that's going to be, what, 80, right? 80 pi over 3. I'm going to double check that, even though I'm like 99%, it's 80. Okay. And 80 is not divisible by 3. And I knew that right off the bat because like 16 is not divisible by 3. 5 is not divisible by 3. It's not going to be divisible by 3. I'll plug it in. Oh, it's 26.6. Okay. So it's not divisible by 3. So here we are in that situation I was just describing, is that this is divisible by 3, but this is not. And if I have to put it all together, big cone minus small cone, then I'm going to have to get a like denominator. So now we have, so volume of the frustum. We have 2160 pi over 3 minus 80 pi over 3. I'm going to subtract those two. Time to go to green. Should have done that in the first place. Volume, frustum. It's green here. I should have done green. Yeah, I should have done green. Let's see here. That's what? 2080 pi over 3. Pretty positive. I've been wrong before. It is correct. Okay, so I can just subtract those numbers and leave the pi, right? And that is my final volume here of said frustum. And that is inches cubed. Boom. Whee, whoop. Nice. And then I can also get a decimal equivalent. Okay, so your decimal equivalent can be done by multiplying, just like typing this in into your calculator. If you hit alpha x or alpha y equals, you can get a fraction, and you can just type it in exactly how you see it, times pi. Your pi is your second caret on the calculator here. So I don't have the emulator up. Here is minor calculation, so I didn't put it up there. And we would get our approximate, got to find some room here. I'll put it in pink so it pops. Our approximate here is 2178.17 cubic inches. So inches cubed. So I put a little squiggly equals to showcase that it is approximate. I have rounded. This is exact in terms of pi. So there you go, guys. A frustum. You might be like, what the frustum, bro? This is crazy. It is crazy. It's a crazy little shape. It takes a lot of work. You get to find the volume of two cones. Even popped in some similarity on this bad boy. That was dope. And thank you guys for watching. If you have any questions, let me know in the comments. Otherwise, thanks for mathing with me.